In this video, we're going to look at compounds that are ionic versus compounds that are molecular, also known as covalent. We'll learn how you can tell them apart based on their formulas, and then we'll look at some important differences between them. So, how can you tell whether something is ionic or molecular? Well, it depends on the elements that make them up. So, ionic compounds are made of metals and nonmetals, whereas molecular, also known as covalent compounds, are made of only nonmetals. Let's do a couple practice problems to work on this. You will need a periodic table to do this. Here's the one that I'm using. I've left out a lot of the elements because they're not important, but what is important is this big, thick staircase that divides the periodic table into two parts. On this side of the staircase are the metals, and on this side of the staircase are the nonmetals. Okay, so here are a couple examples. The first one, sulfur dioxide. So what are the elements it's made of? It's made of sulfur and oxygen. Both of these are nonmetals, which means that sulfur dioxide, SO2, is a molecular compound. Sodium chloride is made of sodium, a metal, and chlorine or chloride, which is a nonmetal. So sodium chloride is an ionic compound. All right, now H2O is made of hydrogen and oxygen. Now you might think that hydrogen is a metal because it's on this side of the periodic table. It's fine, it's understandable if you do that. But hydrogen is an exception. Even though it's on this side of the periodic table, it's actually a nonmetal. It's the only exception. So hydrogen and oxygen are actually both nonmetals, which means that H2O, water, is a molecular or covalent compound. Okay, copper 2 fluoride. Copper is here, fluorine or fluoride is here, metal, nonmetal, so this thing is ionic. Okay, let's look at a few trickier examples. So far, we've only looked at compounds that have two elements in them, but there are a lot of compounds out there that have more than two elements in them, okay? So propanol, for example, is made of carbon, hydrogen, and oxygen. All three of these are nonmetals, though, so this is still a molecular or covalent compound, even though it has a bunch of nonmetals in it, okay? Don't be confused by that. Here's another example. Lithium nitrate has lithium, which is a metal, but then it also has nitrogen and oxygen, which are both nonmetals. So it's still got the metal, nonmetal thing going on, so it's an ionic compound, even though it has two nonmetals. And the same thing is true of sodium sulfate. It's got sodium, a metal, and two nonmetals, sulfur and oxygen, but metal, nonmetal means it's ionic. Now, lithium nitrate and sodium sulfate are actually special kinds of ionic compounds because they have two different nonmetals in them. They are what are called polyatomic ionic compounds. If you want to learn more about these, I've got videos on that. So, now we can look at a chemical formula and we can sort them and we can decide whether something is ionic or whether it's molecular or covalent. So what? Who cares? Well, there are some very important differences between ionic compounds and molecular compounds. Let's take a look at some of those right now. So one really important difference is how the atoms in these compounds are held together. In molecular or covalent compounds, the atoms that make them up are held together because they're sharing electrons. Here's what I mean. Water, H2O, is a very common molecular compound. It's made of one oxygen and two hydrogens, and these lines between the atoms show that they're connected, and they mean that they're connected because they're sharing electrons. Here's how I like to think about this. It's like oxygen and hydrogen both have these little hands, and the hands are joined together. It's like they're holding hands, and they're holding hands because they both are trying to hold on to a pair of electrons, which I've drawn here in red. So we've got oxygen and hydrogen connected together because they're holding on and sharing these electrons here. That's what makes the atoms connect and stick together in a molecular or covalent compound. Okay? Now, on the other hand, in ionic compounds, the atoms aren't being so nice to each other. Okay? They're not sharing. The atoms stick together in an ionic compound because one atom steals another atom's electrons, so electrons get stolen, and then opposite charges attract. Let me show you what I mean. So sodium chloride, or NaCl, is a very common ionic compound. It's made of sodium and chlorine, and here they are just hanging out. Now for these two guys to stick together, here is what happens. The first thing that happens is chlorine reaches its greedy hand over and grabs an electron from sodium, okay, and it pulls it back. So now chlorine has an extra electron and sodium has lost one of its electrons. This causes chlorine to now get a negative charge because it has a new electron, and sodium, because it's had one of its electrons stolen, now it has a positive charge. So now we have a positively charged ion here and another negatively charged ion here. What do opposite charged things like to do? They like to come together. They stick together. They're attracted to each other just like magnets. So now we have a positively charged thing and a negatively charged thing. These arrows show how they're going to come together. And we end up with the two atoms stuck together because they're oppositely charged. And that's what holds ionic compounds together. So covalent or molecular compounds, the atoms are stuck together because they're sharing electrons with each other. Ionic compounds, the atoms are stuck together because one has stolen the other's electrons, it's given them opposite charges, and then those opposite charges have, let me try that again, and then those opposite charges, there we go, have attracted just like magnets. So this is one way that ionic and molecular compounds differ. Here is one more. So another big difference is how these compounds would actually look if we could see the atoms that make them up. So molecular or covalent compounds are made of molecules, which is a fancy word for a bunch of atoms that are stuck together in a clump. Here's what I mean. So sugar is a very common type of covalent compound, and it is made of molecules where I have these atoms here stuck together in a clump. 2 carbons, 4 hydrogens, and 2 oxygens. So a grain of sugar would look like this. It would look like a number of different sugar molecules that have all kind of come together and formed a clump here. Okay, but the big deal here is that these molecules are individual clumps of atoms that then come together to make stuff. On the other hand, ionic compounds, they're not made of clumps of atoms like molecules. They're made of what we call lattice structures. And here's what lattice structures are. The example I'm going to give you is salt, which is sodium chloride, table salt. And the lattice structures of sodium chloride look like this. Look how different this is from the molecules that make up sugar. You just have the sodium and the chloride atoms stuck together in this sort of very organized box-like shape. This is what a lattice structure is. There aren't individual clumps of sodium chloride the way there are individual clumps of sugar. Instead, all the atoms are stuck together in this very regular shape. Now, one big important difference between covalent and molecular stuff and ionics is what happens when they dissolve in water. These guys just come apart into molecules, whereas the individual atoms come apart when an ionic compound dissolves in water. But we're getting a little ahead of ourselves here. If you're interested in other differences between these, check out videos that I have on the physical properties as well as what happens when you dissolve ionic and molecular compounds.